Hello everyone, I am Mr. P.Y.Kumbhar. Welcome to this session. Today we want to see the frequency division multiple access, that is FDMA. The learning outcome of this topic is at the end of the session student will be able to explain the concept of frequency division multiple access, that is FDMA. The contents of these topics are, first of all, we want to see the introduction of FDMA, then features of a FDMA, then non-linear effects of a FDMA, and after that one we want to see the one numerical problem on the FDMA. Now, the frequency division multiple access, that is FDMA. Now this figure shows FDMA where the different channels are assigned different frequency bands. So in this diagram, X, Y and the Z axis. So here there are time, frequency and the code is available. Now there are different n number of channels are available. So this frequency division multiple access, that is FDMA, assigns individual channels to individual users. It can be seen from that figure 1 that each user is allocated a unique frequency band or channel. So these channels are assigned on the demand to users who request the service. During the period of the call, no other users can share the same channel. So in FDD systems, the users are assigned a channel as a pair of frequencies. One frequency is used for the forward channel while the other frequency is used for the reverse channel. Now we want to see the features of a FDMA are as follows. The FDMA channel carries only one phone circuit at a time. If an FDMA channel is not in use, then it sites idle and cannot be used by other users to increase or share the capacity. It is essentially a wasted resource. After the assigned of a voice channel, the base station and the mobile transmit simultaneously and continuously. The bandwidth of FDMA channels are relatively narrow, that is in 30 kHz in the AMPS, as each channel supports only one circuit per carrier. That is, FDMA is usually implemented in narrowband systems. The symbol time of a narrowband signal is large as compared to the average delay spread. So this implies that the amount of inter-symbol interference, that is ISI, is low and thus little or no equation is required in FDMA narrowband system. The complexity of a FDMA mobile system is lower when compared to TDMA system. Though this is a changing as digital signal processing methods improve for TDMA. Since FDMA is a continuous transmission schemes, fewer bits are needed for overhead purposes such as synchronization and the framing bits as compared to TDMA. FDMA systems have higher cell site system cost as compared to TDMA system because of the single channel per carrier design and the needs to use costly bandpass filters to eliminate spurious radiation at the base station. The FDMA mobile unit uses duplexers since both the transmitter and the receiver operate at the same time. This results in an increase in the cost of FDMA subscriber units and the base station. So FDMA requires tight RF filtering to minimize adjacent channel interference. Now we want to see the non-linear effects in a FDMA. In a FDMA system, many channels share the same antenna at the base station. The power amplifiers or the power combiners, when operated at or near saturation, for maximum power efficiency are non-linear. The non-linearities causes signal spreading in the frequency domain and generate intermodulation frequency, that is IM frequency. Now frequencies intermodulation frequencies is undesired RF radiation which can interface with other channels in the FDMA system. Spreading of the spectrum results in adjacent channel interference, that is ACI. Now, intermodulation is the generation of undesirable harmonics. Harmonics generated outside the mobile radio band causes the interference to adjacent services, while those present inside the band cause the interference to other user in the wireless system. The first US among the cellular system, the advanced mobile phone system, that is AMPS, is based on the FDMA/FDD. A single user occupies a single channel while the call is in a progress, and the single channel is actually two simplex channel which are frequency duplexed with a 45 MHz split. When a call is completed or when a handoff occurs, the channel is vacated so that another mobile subscriber may use it. Multiple or simultaneous users are accommodated in a AMPS by giving each user a unique channel. Voice signals are sent on the forward channel from the base station to mobile unit and the reverse channel from the mobile unit to the base station. In AMPS, analog narrow band frequency modulation, that is NBFM, is used to modulate the carrier. Now, the number of channels that can be simultaneously supported in a FDMA system is given by N is equal to BT minus 2B guard divided by BC, where BT is the total spectrum allocation, B guard is the guard band allocated at the edge of the allocated spectrum band, and BC is the channel bandwidth. Note that BT and the BC may be specified in terms of a simplex bandwidth, where it is the understood that there are symmetric frequency allocation for the forward band and the reverse band. Now we want to see the example. Okay, in this example, the question is, if a US AMPS cellular operator is allocated 12.5 megahertz for each simplex band, that is BT is 12.5 megahertz. So I will written here BT as a 12.5 megahertz. B guard they are given as a 10 kilohertz, that is a 10 kilohertz, and BC is a 30 kilohertz. So here I want to find out the number of channels available in a FDMA system. So now as we seen that the formula for number of channels, that is N, is equal to BT minus 2B guard divided by BC. Now we know that what is, suppose this is the equation number 1. Now I will put these values into this equation number 1. Therefore N is equal to, what is the BT? 12.5 megahertz. So I want to convert this megahertz into the hertz. 12.5 into 10 raised to 6 hertz minus 2 into B guard. B guard value is 10 kilohertz, that is 10 into 10 raised to 3 hertz, divided by BC, that is 30 kilohertz, that is 30 into 10 raised to 3. Now when you want to solve this problem, so we will get the answer N is equal to 416. N is equal to what? 416. Therefore what we conclude here? Here number of channels available for given specification. Now here given specification means what? This one. This is a specification they provide. For given specification in FDMA is in FDMA is 416. 416. So this is a example. The references for these topics are. Thank you.